And now I want to move to just some basics about how the internet works. So this is stuff which I think you need to be aware of, even in the most simplest form. And many of you will be aware of this already, but I just wanted to kind of just glance over it to make sure that everyone in the course has a basic understanding of various things like domains and the ownership of domains, the DNS system and servers and so on, so that things aren't extremely confusing this week when we go over rolling out servers and a tracking system. So I'll go over a few of these things now, and then in later modules this week we're actually going to do very, very practical hands-on tasks related to all of these. So if there's any confusion about what the hell you're even doing with these, don't worry, that will be washed away when you actually get your hands dirty. So you'll all be familiar with domains. You'll either have bought one in the past, or you will have bought one since the 6-week challenge started. Domains, very, very simple. They're just basically a name and a phone book. They cost you between $5 and $100 per year, depending on the TLD, or the domain extension, of which there are many of them. They point to a set of name servers, which are kind of like the phone book directory, which tells you where that address is actually meant to point, where that's meant to eventuate. And all of those domains have registrant details. So when you do register them, you have to put in some details. Typically, you'd use something like whoisguard to obscure them. One thing you should be aware of is that due to recent law changes by ICANN, you are required to verify your email address when you register new domains. And this is kind of to stop anonymous people registering thousands and millions of domains and never actually verifying their ownership. Just kind of new stuff brought in. They were actually thinking of taking away domain ownership obfuscation. So the whoisguard technology, they were thinking of removing that. It's kind of not a great thing, because when you register a random domain just to use for some one-off thing, especially in the affiliate marketing industry, you really don't want your private personal information attached for it, because that would mean anyone who sees your campaign could look it up and could tell your name and address, and obviously that's a serious privacy concern. Some people would argue, if you're going to buy a domain for your business, you should be not proud of, you should be liable for that domain and you should put your name behind it, but that's kind of rubbish. No one wants to actually do that. Now, in any case, domains point to a set of name servers, and once we get to name servers, we're working with the DNS. I tend to say DNS system, but DNS means domain name system, but saying the DNS just kind of sounds a bit awkward, as does the DEN system, so you'll have to permit my misnomer there. So, what does the DNS system do? Essentially, its job is to translate human-readable semantic addresses like www.domain.com to the IP addresses that the internet and servers and computers use to communicate. So we start with the DNS zone for a specific domain or subdomain. This is the initial thing that all of the DNS related work you do starts with, a zone. So that zone might be domain.com or www.domain.com. Be aware that www is actually a subdomain of domain.com. It's just the one we by convention use for websites hosted on that server. Or you might have asterisks like wildcard anything.domain.com. This is what you would make at a DNS related platform for controlling your DNS entries. You start with the zone. This is kind of like your name in the phone book. Now within each of those zones, you have a collection of records. So stuff like home phone number, work phone number, fax number, and these records in the DNS system are called A records. A records have relate to IP addresses. CNAME records means canonical name. It's kind of like an alias where you want say you want blog.domain.com to actually point to a completely different address or kind of mask it. MX, this is for mail records, for email. Text, this allows you to just have text strings and content with your domain. There's many other record types as well, but we won't really get into them. Now each of those records contains an answer or a response. So for example, you have your zone, which might be AJ Smith, and then you have a home phone number, that would be the record, and then you have an answer or response, which would be the phone number. So it's actually a very good analogy there. Now, each of these records contains an answer or response that other systems can retrieve. So if I'm in a browser and I go to www.domain.com, various things happen in the background, but I request information from the name servers of www.domain.com. It resolves to other name servers, and it looks for a record associated with that domain, with that zone, and it gets various answers and information which then tell me, the user, or tell my computer, my browser, my ISP, whatever, tells me what to do, where to go. So we're going to use a DNS service such as NS1. Now you can use almost any service, there's quite a lot of them. NS1, Amazon Route 53, DYN, DNS Made Easy. There's really a lot of them. Rackspace has their own DNS platform as well. I think Cloud DNS, Cloudflare has its own DNS service as well. There's many of them. Now, there's not really a huge difference between them. There's differences in functionality and what you can do and pricing and things. In terms of the impact it has on your campaigns, it's very, very small. It's one of the minor components of everything you do, because once you actually resolve an address, that kind of gets cached by a lot of systems in the internet infrastructure, which then means regardless of the actual platform you're using, subsequent requests may only take 1 millisecond. So the impact of DNS is actually quite low, but it pays to use a good platform from the beginning. Now, NS1 is not, it's relatively expensive if you're doing volume, but you're not to start. And the reason I suggest this platform is because it's just got a really nice interface that makes it really easy to learn how to actually configure these systems. And then later you can move to whatever platform you want. If you understand how the DNS works, then it doesn't matter what platform you're using, you kind of know what you're doing. So this DNS service allows us to control our zones, our records, and those answers. One thing I did want to mention is that you can use your server that you're hosting your site on as your DNS name server as well. You can run DNS services even on your computer, but also on a server you have. But I highly, highly do not recommend this. Why do I not recommend that? Because this point puts something quite critical on a server which can fail, and that is a very, very a critical thing you do not want to do. When there's cloud-based systems where there's redundancies and there's backups and they literally just will not go down in most circumstances, you want to use those. You don't want to put everything on your server, which when you reboot it, for example, takes your DNS down, which might cause emails to bounce, people can't visit your sites, and then incorrect or failed results and responses might get cached. They might take a day to actually expire. You don't want to do any of that. So just trust me, use the DNS system that I'm telling you to use. Now, why do I think you need to understand the DNS? Well, it can kind of be a source of failure in your infrastructure. Although it won't affect speed that much, things like incorrect configurations and outages and doing something silly like putting it on your server, that can have a critical impact on your actual campaigns and people visiting your site. So it's very, very important that you kind of understand how the DNS system works. Now, the other thing is when we're doing kind of more creative stuff and we're dealing with tracking systems and you're dealing with CNAMing and masking and various things, it kind of pays to know how the DNS system works so that you can figure things out. And similarly, when you encounter DNS errors, for example, you can't load a site and you know that there's something wrong with something in the domain name system, what you can do is use a VPN, because you know that changes your DNS resolvers and you can see whether that resolves the site and so on. So if you do understand the system, it kind of just gives you a better awareness of the internet infrastructure as a whole. Now, what I have done is made a map of how the DNS system works for you guys to look at and probably be very confused by, but I recommend you look at this map a few times and kind of just see if you can figure out what's actually going on there. So I'll cut to this map now, and what I've essentially tried to do is build a map from start to finish. So you start with your registrar, for example, Namecheap, where you buy a domain name, and you have name servers, which you set on your registrar. Now, when you actually set those name server settings, it's not actually stored at Namecheap. Well, it is, but that's not the important place that it's stored. Those name server settings actually get pushed to something called the root name servers. Now, the root name servers are name servers for these top-level domains, these extensions like .com, .org, .net. These root name servers are absolutely critically important to the internet itself. If the root name servers went down, you literally would not be able to access, or at least for a while, you would not be able to access sites using that domain extension on the internet. Obviously, that would be terribly bad. For that reason, there are redundancies. I think there's 14 root name servers around the globe. Honestly, can't remember, but there's quite a few of them. They're distributed across sort of redundant networks. The locations of some of them are actually shrouded in secrecy and not known, so that if someone wanted to do a coordinated attack, they couldn't actually find all of the name servers. And when people actually do certain specific updates to those name servers, it's actually quite interesting if you look it up, but I believe ICANN, I-C-A-N-N, the sort of authoritative body that controls and oversees the name servers and the DNS system, I believe to go make certain changes to the root name servers, they actually have to go into an underground bunker, which has very, very tight sort of military security because it is kind of a critical point in the entire internet. They all have to take master keys and go down there with no electronics on them into a completely sealed area where they have to use all these keys simultaneously to get, root access to these name servers to change anything. It's pretty crazy, but kind of cool in a very, very geeky way. Anyway, what I wanted to say is when you set your name server settings, they actually get pushed to the root name server. So there's a .com name server somewhere holding the details for domain.com. And the details it's holding are your name servers, like DNS1 or whatever, .ns1.net. Like whatever DNS service you're using, those name server settings are being stored at a root name server. And these are called the authoritative name server. Now that's where everything gets stored. Now let's look at things from the other end, say from you, the user. So when you're a user and you make a request, what happens is that request goes through many, many steps to find an answer, to resolve that question, which is why we call it DNS resolution. And there's a lot of caches involved on the way. So you type in www.affiliatemasterychallenge.com in your browser and you hit enter. The first thing that happens is your browser checks its own sort of cache, its mini DNS cache, and it sees if that value, that answer, is already stored there. Now, any stored answers anywhere in any of these caches, they have an expiry. This is something that you can set. Generally, it's called a TTL, or time to live, and this might be 7 days, for example, in seconds. So whenever you get that answer, it says at 5 p.m. on a Saturday, I got this answer is valid for 7 days. So your browser looks in its cache and sees if that answer is there. If that answer is there and it's valid, it hasn't expired, it uses it immediately. If it has expired, it goes to your operating system and asks that, because your operating system actually has its own cache. If there's no valid, non-expired answer there, it actually goes to your router. Your router can have a cache. Now, in some cases, this might not actually happen. You can turn caches off in various places, but for all intents and purposes, just imagine these are all active. So then it asks your router. So an example here would be you're on a shared network, right? Someone in your apartment has looked at Affiliate Mastery Challenge yesterday. Now you have never seen it before. You go to load it. It actually asks your browser, then your operating system, then your router, finds there's a cached entry, returns that entry. It takes 2 milliseconds and you get an answer, and that's it. It's a nice closed loop and it's very fast and efficient. So the DNS system is kind of based on many, many caching points to make things very, very efficient. Now, if your router doesn't have it, it goes to a DNS resolver. This is generally controlled by your ISP. Now, this DNS resolver is something you can typically change. So if you've ever changed settings in your computer or your browser, to use different DNS services or DNS IPs. Say you've done this in your network connection settings. You might use Google's DNS, for example, where the IP is 8.8.8.8 or 8.8.4.4. What you're doing there is you're replacing this DNS resolver that typically your ISP uses. Now your ISP centralizes everything and it has its own cache. So if someone else on your ISP has looked up affiliatemasterychallenge.com 30 minutes ago, it's certainly in the ISP's cache and they're not going to look it up again. They're just going to give you the answer. Now, one thing you should be aware of as well is that these TTLs that you set at your DNS service, like NS1, these specific expiries in seconds, be aware that it's a standard for systems to actually honor these, but some systems won't. They just don't care, so you have to deal with that. Anyway, I'll try to shorten this up a bit. So your ISP looks in their cache. If it's not there, then what they're going to do is they're going to start a cascading DNS query. So I'm looking for www.affiliatemasterychallenge.com. The first thing the DNS resolver is going to do is ask the .com name server and say, hey, I need the authoritative name server for affiliatemasterychallenge.com. That request goes away. The .com root name server says, here you go, ns1.nameserver.com is the authoritative name server. And the DNS resolver goes, okay, awesome. Now it then contacts that and says, hey, I need, oh, there's one step I missed in there. There's the root name server, which has the entries for, or the name servers for .com, .net, .org, and so on. So I kind of misnomed it at the start there, which is should make things a little bit clearer now. There's several root name servers which contain all the entries for the authoritative name servers for .com, .net, whatever. So obviously there's more than 14 of those because there's more than 14 TLDs, but there's 14 root name servers. So you can imagine how important they are, because if you change the .com entry, no one would be able to resolve .coms correctly at all. Anyway, we ask the root name server first. We say we're looking for .com. It says try the .com name server. We go okay. We ask the .com name server for affiliatemasterychallenge.com. It replies with try ns1.nameserver.com. Okay. We look for ns1.nameserver.com. At that point, it goes to ns1. That is when we start using the name server that we've set out our registrar, and that's when we contact NS1 and we say, hey, we're looking for affiliatemasterychallenge.com. Do you have that? It says yes. Then what it does is it replies with the subsequent or the corresponding A record or whatever record we're looking for, and actually gives us an answer. Now, if we are looking for www.affiliatemasterychallenge.com, it would actually ask for affiliatemasterychallenge.com first. NS1 would say, yep, I've got that. What else do you want? And then our DNS resolver would say, I want www, and it would go, okay, and respond with the answer. So this is a bit drawn out and a bit long, but what I really wanted to do here was give you a very, very thorough understanding of how DNS resolution works, because honestly, there are so many times when a silly little problem comes up where it's a DNS error or you've set configuration in your DNS system wrong and you have no idea what's going on. These are the things I kind of want you to avoid, the pitfalls that I want you to avoid to save you time. Okay, now moving on from that, we can talk about servers. So, servers. First of all, sorry for the big waffle about DNS. You can fast forward through that. So in retrospect, you're probably not going to realize that at the time, but you could probably have skipped that. But I think the DNS system is really elegant and I just kind of like it. But I'm a big tech geek, so kind of ignore everything that I say if you don't like tech stuff. Anyway, servers. What the hell's a server? So a server is just a computer. It's exactly or kind of similar to the computer you are probably using right now in at least 80% of the ways it actually works. This server has an outward connection to the internet, generally a static IP or a static address, and as opposed to your PC or your laptop, whatever you're using, it's configured to accept many, many incoming connections. Now, these connections and this communication, they happen through ports. So there's many ports between 1 and 65,536, I think is the range, so quite a lot of them. But there's various common ones that are used all the time. Port 21 is for FTP. Port 80 is the default port, which is where web or HTTP communication happens. So when you look up www.affiliatemasterychallenge.com, when you don't have a port specified, like with a colon and then some port, that actually uses port 80 because that is the default. 443 is for SSL or for secure communications. So when you write https:// some address, what that is essentially doing is defaulting to port 443. That's the port it tries to communicate with that server or that address with, because that's the default for secure communications. And there's lots of different ports that are involved with servers which you'll encounter over your lifetime if you're doing relative technical stuff, like SSH, for example, is port 22 rather than port 21. Now, like all computers, the performance of a server will vary with hardware, networking, ISP, configuration, routing, load, all of these kinds of things. So just like your computer, or your hardware specs in your laptop or your desktop, the performance of a server is very hardware specific, and it also depends on the software configuration, the actual internet connectivity, and various things. And like all computers, it can crash. And there are many types of servers that you can actually use, or you can purchase and use for your campaigns, for tracking systems and so on, websites. There's shared hosting. Shared hosting is the most terrible thing that you should stay away from. If you have shared hosting, please just be aware that I'm going to make you get rid of that unless it's super important for some reason. There's no reason to use shared hosting. I mean, you can get it for like $3 a month or $10 a year or something, but to be honest, shared hosting is just so crap. You should get rid of it. Why is it crap? Essentially because you're sharing your hosting space or your resources of your server with 100 to 1,000 other people. It's like 100 to 1,000 people sharing the same house, the same bathrooms, where essentially there's competition for all of those resources. And that means that at any point in time, someone else doing something can impact the performance of your hosting and your site. And for this reason, you should just never use it. If you install a tracking system or run affiliate campaigns on shared hosting, I am going to slap you through the internet. So do not do that. Virtual private servers are kind of the next level up. So a virtual private server is kind of like a little sandboxed container for your site. Now, there's still a little bit of sharing of resources, but it's a lot better than shared hosting. Typically, you have a certain number of cores you have access to, a certain amount of dedicated RAM, which is yours alone. No one else gets to use it. Certain amount of hard disk space, no one else gets to use that. Sometimes you have burstable RAM, where it's shared and you can kind of steal some in bursts to use more than your plan allows for, because not all of the servers on the computer are using all of their RAM at any one time. And for all intents and purposes, they're kind of sandbox. They're very useful in many ways because virtual private servers you can generally roll out and create very quickly, then you can destroy them. They're very easy to work with and very flexible. So there's a lot of pros and cons, but for the most part, it's all pro, especially versus shared hosting. And then the next level up is a dedicated server. And this is when you have your own dedicated hardware. No one else uses any of it. And it's just a computer or a server sitting somewhere in some data center where it's yours alone. Performance-wise, you're never going to beat these with a virtual private server. That just, all else being equal, the same hardware, logically, that does not make sense. It's like saying in a house living alone, you're versus living with 3 other people. In the house when you're living alone, you can pretty adamantly say that you've got less chance of having someone else using the bathroom when you go to use it, right? So dedicated servers, the performance is way up there, but then you have less flexibility in certain ways. So you generally can't just rebuild, destroy, and re-implement and mirror and copy dedicated servers on the fly like you can with a virtual private server. Virtual private server, because it's using a certain number of resources from a larger server. So you might have a large server which has 8 CPU cores or 2 CPUs, 64 to 128 gigabytes of RAM, solid state drives, maybe 4 of them, all with like a terabyte each. You might have 20 VPSs on that server where each one is using a certain core on a certain CPU and is using a certain amount of RAM, and you can kind of scale these on demand if there is resources available. Because of the nature of these systems, hosts can actually delocalize them, so they can move them around between amongst different hardware on the fly when you're wanting to upgrade. So you can kind of pause your VPS or shut it down, and in 5 minutes you can add more RAM to it, then turn it back on, and voila, you're done. Dedicated server, someone kind of physically needs to open that up and put stuff in there to upgrade things. So again, pros and cons. Now, I'm being deliberately quite elaborate here for a reason. And that reason is we're actually going to do some practical tasks very, very soon involving all of this. So I'm going to teach you how to set up a virtual private server, and I'm going to make it very, very easy for you to do that. It's going to be very cheap, only costs $10 a month or even less. We're going to set up DNS entries, we're going to install and set up a tracking system, and we're going to use things like PHP to do some little experiments and test some things, where we're going to practice some server admin, we're going to make FTP accounts and learn how to use FTP. We're going to do all of these things, so I kind of just wanted to portray and put across some very fundamental basic stuff just for those people where this is all relatively new and they're not very tech orientated. I know for the majority of you, I'll probably be teaching you how to suck eggs and you can skip through all of this. Really, it won't offend me at all. But I really just wanted to give this fundamental ground framework for those of you who do appreciate it. Now, that's everything I wanted to talk about in this little module. Now, in terms of tasks for today, I want you to review the information on DNS. And if you have any questions on that, please just ask immediately. I think it's very important to make sure you understand the domain name system early on before we get deep into configuration, where mistakes can kind of hold you back because you'll make a mistake in some record. For example, in records you never have protocols like HTTP, you never have folder and file names like slashes and things. Something I didn't mention before, the DNS system is domain name system, just names. So in any record you do, any A record, C name record, whatever, other than like text records, which can kind of have anything, A records, C name records, you never have protocols. You never write HTTP:// in this, and you never have paths. So you would never write something or other .com/folder name. No slashes, no folders, never do that. It's just this core name part that comes between all of that. Anyway, so what I want you to do is review the information on DNS, ask if you have any questions. Anyway, that's it. I will stop talking, promise, finish for now, and I'll see you in the next video.